Hello and welcome to section 7.2 where we're going to add and subtract rational expressions. So we're going to add and subtract expressions with common denominators, with unlike denominators, expressions whose denominators are opposite, and then we're going to talk about how to find the least common denominator. So let's get started. Okay, so adding and subtracting rational expressions is just like adding and subtracting fractions. Let's say, for instance, you want to do, let's say we're adding 1/4 and 2/4. It's the denominators are the same. We add across the top. That's 3/4. Okay, and same for subtraction. So using that, here we have 11x plus 28 over x plus 4 plus x squared over x plus 4. Since the denominators are the same, we can just add across the top. Now this looks like, this numerator looks like it could possibly be factorable, right? So we have x squared. Let's write it in the correct order. So 2 factors of 28 that when added together give me 11. And if you said 4 and 7, that's correct. So let's go ahead and factor that. We get x plus 4, x plus 7. In the denominator, you have x plus 4. These cancel. Final answer, x plus 7. Okay, let's do one where we subtract. So you're subtracting the entire numerator. So that means you're going to have to distribute the negative. So we have here 5x squared minus 7x plus 3 minus 4x squared minus x plus 9. And that's all over the common denominator, x squared minus 3x minus 18. So let's go ahead and do like terms. So 5x squared minus 4x squared is just x squared. Negative 7x combined with a negative x is negative 8x. And you have a positive 3 and a positive 9, so that combines to become 12. And that's all over here. Now, are there 2 factors of negative 18 that when combined give me negative 3? Yes. So let's go ahead and factor that. So x minus 6, x plus 3. And then on the top, 2 factors of a positive 12. When I combine it, I get negative 8. If you said negative 2 and negative 6, you are correct. So the top factor is 2x minus 2, x minus 6 over x minus 6 times x plus 3. Okay, cancel out the factors that we have in common. And your final answer is, here, I guess I'll write that here, x minus 2 over x plus 3. Not too bad. Let's go ahead and do another one. This is the case where you have denominators that are opposites. Okay, so one thing to remember is that you have, if you have a difference, it's the same as the opposite of, and then you write it in a different order. Okay. So you can always switch the order, but if you want to keep the integrity of the problem, you have to make sure that you take out the negative, right? You have to make sure of that. So let's say, for instance, you have 3 minus 2. That's the same as the negation of 2 minus 3. So 1 is equal to negative of a negative 1. So that's true. Okay, so let's go ahead and do that here. So the first one, m squared minus 6m over m squared minus 1. I'm going to take this 1 minus m squared and I'm going to replace it with negative m squared minus 1. Okay, so I'm just going to do that first so you can see what I'm talking about. Negative m squared minus 1. Now this negative can apply to the top or the bottom, so you can imagine what's going to happen with these 2 negatives. It's going to become positive. Okay, so this is actually going to become an addition problem. So we get m squared minus 6m plus 3m plus 2 all over m squared minus 1. So like terms, we get m squared minus 3m plus 2 over m squared minus 1. The top factors to m minus 2, m minus 1. And the denominator factors to m plus 1, m minus 1. So then canceling out the common factor, we're left with m minus 2 over m plus 1, and that's it. Okay, great. So we've done that. Now, how would we find least common denominator of rational expressions? How do we do that in using, ordinary numbers? So let's say I want to add, 1 12, and I want to add 1/3 to it. So in this case, we would factor. We would realize that 12 is 4 times 3. So the second fraction, we would multiply top and bottom by what's missing to get the 12. So then we would write its equivalent fraction and then go ahead and add. So the same logic applies to adding rational expressions that have unlike denominators. So let's practice finding the LCD. Okay, so we need to, the first step is we need to factor each denominator completely, list the factors, okay? So here we have x squared minus 2x minus 3. That factors to become x minus 3, x plus 1. And then we have x squared plus 4x plus 3. So then that's going to factor to become x plus 3, x plus 1. Okay, so then we have here a common factor. So the LCD, so first you're going to count what they have in common. So they have the x plus 1 in common. So we're going to write that x plus 1. And then we have an x minus 3 and an x plus 3. And that's your LCD. Okay. So that's your LCD here for that. So then we need, so the second part, we write them as equivalent rational expressions with the lowest common denominator. So we would do similar, right? We would multiply both by what's missing. So for the first one, 8 over x minus 3x plus 1, I just rewrote it as factoring so we could see what we need to multiply by. The first one, we would have to multiply by x plus 3 to the top and the bottom, of course. So you're going to get 8 times x plus 3 all over the LCD, which is x plus 1, x minus 3, x plus 3. And then the second one is 3x over, and then in factored form, it's x plus 1, x plus 3. So what are we missing? We're missing an x minus 3 to both the top and the bottom. Okay, so your final answer is 3x times the quantity x minus 3 all over the LCD, which is x plus 1, x plus 3, x minus 3. Okay, so how do we add these rational expressions with unlike denominators? So we see if there's any common factors and we keep those, and if we find the LCD and then we multiply top and bottom each rational expression, and then we combine them. Okay, so in this case here, what would be my LCD? X minus 3 and x plus 2 and x minus 2 are already in factored form, so your LCD, you can't factor them any further, so it's just going to be the product of the two. Okay, so what does that mean? That means I need to change both of these to have this denominator, so that's fine. So we have 3 over x minus 3, and I'm going to multiply top and bottom by x minus 2. So make sure that you understand you're multiplying the entire denominator. Okay, and then plus, and then that's going to be 2 over x minus 2. And then I'm going to multiply top and bottom by what's missing. In this case, I'm missing x minus 3. Okay, now I have the same denominator, so I can just, combine across the top. So 3 times x minus 2 plus 2 times x minus 3 all over the LCD x minus 3, x minus 2. Doesn't matter what order it is. Okay, so let's distribute and then combine like terms. We get 3x minus 6 plus 2x minus 6 all over the LCD. And then we have here, let's go ahead and do like terms. So we get 5x plus, I mean, actually minus 6, minus 12 all over, and then that's the LCD here. We can leave it in factored form, and that's your final answer. Okay, we've simplified. We've added those two together. Okay, so in general, to add or subtract rational expressions, if they have a common denominator, we just go ahead and add across the top. And if they don't, we need to rewrite each one with the LCD and then add across the top. So let's do a few more examples here. Oh, I think we did this one already, actually. So let's do this one here. We have 8y over, and then y squared minus 16 factors to y plus 4, y minus 4. So the second one is going to miss a factor of y plus 4. Y plus 4. So then that's going to be minus 4 times y plus 4 all over the same thing, y minus 4, y plus 4. So now I have the same LCD. So then that's going to be 8y minus, so this negative here applies to this 4, which gets distributed. So then that's minus 4y minus 16 all over the LCD, y minus 4, y plus 4. Okay, so that's just going to be 4y minus 16 on the top, minus 16, divided by this LCD here. Now, are we done? This has a common factor of 4, so let's go ahead and take that out. Y minus 4 all over, and then do we see what happens? Yes, you see that there's a common factor. Let's cross him out. So that's 4 over y plus 4, and we're done. Okay, let's do another example here. So we have here 4 over, and I'm going to factor this, 4 over, just to save space, a plus 5, a plus 1. And how did I find those numbers? Remember, factors of 5 that combine become the middle. Okay, and then minus 3 over, and then the factors of 10 when combined to become 7 is a plus 2. It's 5 and 2. I don't know why I wrote a y here. Sorry about that. This is an a. Okay, fine. So what's my LCD? My LCD, well, what do they have in common? They already have the a plus 5 in common. That's fine. Then we have an a plus 1 and an a plus 2. So that's my LCD. Okay, so the first one is going to be multiplied by an a plus 2 to the top and the bottom. And the second one is going to be, we're going to multiply top and bottom by a plus 1 because that's what's missing. Okay, so then on writing this out, 4a, distributing 4a plus 8 all over the LCD. Okay, minus 3 times the quantity a minus 1. So then that's going to be, actually can write this all in one shot, actually. Minus 3a minus 3, and then leave the LCD. So then that's going to be, a minus 4a minus 3a gives me 1a, so just a. And then 8 minus 3 is 5, so a plus 5 over a plus 5, a plus 1, a plus 2. Oh, wait a second. This is as if it was 1 times this, right? So these can cancel. Your final answer, 1 over a plus 1 times a plus 2. And we're done. Whoa, what did I do? And we're not that done. Okay, yeah, there it is. Okay, yeah. I don't know what just happened. Okay, yeah. Okay, let's do a function. Find r of x is equal to f of x minus g of x. So it's the same thing, except now that we're doing it's an equation, right? It's an equality. It's a function. It has a name. So r of x is equal to, so r of x equals, and then f of x is x plus 5 over x minus 2 minus g of x, which is 5x plus 18 over, and then x squared, I'm going to go ahead and factor that, x plus 2, x minus 2. That's difference of squares there. So we can easily see what's missing from the first equation. It's an x plus 2. Remember that you're multiplying the entire denominator and the entire numerator. Okay, so for the first part, we have x squared, and then you can go ahead and use FOIL or whatever. So, this is going to be 7x, and then this is going to be 10 all over x minus 2, x plus 2. And that's going to be minus 5x plus 18 over the same thing. It's 2, x minus 2. So writing it in one numerator, that's x squared plus 5x plus 7x, sorry, plus 10. That looks terrible. That's a 7, not a 5. 7x plus 10, 7. Minus 5x minus 18, because of this negative, right? We have to distribute. We're subtracting the entire numerator, and that's over x plus 2x minus 2. Okay, simplifying here, we get x squared. 7 minus 5x is 2x. 10, positive 10 minus 18 is minus 8. All over x plus 2, x minus 2. Let's see if the numerator factors. What are two factors of negative 8 that when combined give you a positive 2, x plus 4, and then x minus 2, right? 4 times negative 2. Okay, fine. And then that's all over the denominator, x plus 2, x minus 2. So let's cancel out the common, and then final answer, r of x, that's the name of all of this, is equal to x plus 4, x plus 2 over x plus 2. Okay, and that's it for this section. Here's your super fun homework. Happy studying, good luck, and I will see you in the next video.